Hi, I welcome you all for the wireless communication lecture module. In this session we are going to discuss about the improving coverage and the capacity in cellular system. So as the demand of wireless service increases, the number of channels assigned to a cell eventually become insufficient to require a more number of users. As the number of users increases, we must increase the channel to accommodate that more number of users. Obviously, we are insufficient number of channel to allocate or to manage a number of users in a particular geographical area. So at this point, the cellular design techniques are some techniques which are used to increase the coverage in a particular area. Okay, those techniques are called as cell splitting, sectoring, and a coverage zone approaches. These are some approaches which increases the cellular capacity in a particular area. This will enhance the number of channel assigned to a particular users. Thereby, it increases the capacity and accommodate more number of users in a particular area. So, the first we will discuss about a cell splitting. So, cell splitting is nothing but if, for example, if you consider here a cell which is more consistent, that cell has to be broken into n number of smaller cells. Okay, so for each smaller cell we can assign one different base station with a reduced height. Okay, so that it can act independently. It can transmit the power within that smaller area with the help of a low power transmitter. So this is the concept of a cell splitting. Consider, yes, we are considering a cell which is more consistent. Normally we cannot able to accommodate more number of users in that particular cell. So if we want to manage the consistent number of users, obviously what we are doing now, we are going to divide, or we are going to split the cell into n number of smaller cells. Okay, and these smaller cells, that itself will act as a one cell. Okay, that small cell itself have a base station, and it is going to have an antenna with a lesser height, and it is going to transmit power with a low power. So by the way, that cell or that splitted cell will act as a independent cell. Thereby it can accommodate a more number of users. This concept is called as a cell splitting. Okay, so normally the cell splitting increases the cellular capacity system. Okay, so the number of channels are reused, that will increases. Because of that, the capacity will also gets a increases. Okay, and these cells, we are splitting a cell into smaller cell. That smaller cell is normally called as a micro cell. Okay, so the increased number of cells would increase the number of clusters over the coverage region, which in turn would increases the number of channels. As I have mentioned, if the number of cells it gets increases, the number of cells in a particular cluster will get increases. Obviously, the frequency reuse concepts will get increases. So the number of channel assigned to particular area will get increases. Okay, okay, so for example, look at the diagram. So here, consider the cell at A. Okay, this is placed at the center. No, so we are, if we are dividing this into smaller cell, now look at the point A. Now it has a original base station A, which is surrounded by a six. If you are dividing this cells into small cell, now that A has been surrounded by the base station surrounded by a small micro cells. Okay, so the smaller cells were added in such a way that to preserve frequency reuse plans in the system. We can reuse the same frequency in a different cells. That will enhance the capacity. Okay, and then, the major important thing is, whenever we are splitting the cell into smaller cell, obviously the power which is the transmitting power from the base station, that will be reduced. That is the one greater advantage of the splitting a cell into smaller cells. For example, considering we are going to consider a cell and a smaller cell. In say a old cell is normally called as a cell, and new cell is the cell which we are dividing into smaller cell. Normally it is a micro cell. So the power required when it is not divided, that is denoted as PT1. Okay, directly proportional to PT1, which is into the R power minus n. N is the path loss component, which is represented in equation 44. Now we are dividing the cell into smaller cell, micro cell. Now the power is directly proportional to PT2. Okay, R divided by 2, that is whole power minus n. Okay, so here the PT1, PT2 are the transmitted powers for the and before the cell is splitting this PT1, after the cell is splitting into microcell, that is called as PT2. N is a path loss component. Now the PT2 is the power of transmitted for after splitting the cell is equal to PT1 divided by 16. That much amount of power is reduced when we are splitting the cell into smaller cells. In other words, we can say that as the transmit power has reduced to 12 dB. Okay, when compared to the previous one. So it has to be maintained at 12 dB so that that signal to interference ratio will not occur. It has to be reduced and it has to be maintained like this so that the microcell cannot have an interference with the another microcell. Okay, that is the concept of cell splitting. A concentric cell is divided into n number of small cells, and each small cell will act as each microcell will act as a cell. It has its own base station, it has its own number of channel, it has its own transmitting power. Okay, that's the concept of a cell splitting. And the second one to improve the capacity is cell sectoring. Cell sectoring is nothing but it increases the signal to interference ratio. Okay, by reducing the cluster size. In this approach, instead of using a omnidirectional antenna that are being replaced by the directional antenna, and then each directional antenna will cover only certain particular sector of a cell. So here we are going to divide the cell into n number of sectors, and that with the help of a directional antenna, the coverage is going to be cover only that particular area. This concept is called as a cell spectoring. Okay. So by using a directional antenna, the receiver interference and transmit only with that particular area. Okay, it is not going to bother about the all the other areas. Thereby, it increases the system performance by using the directional antennas. Okay, so the factor by which the co-channel interference is reduced by number of sectoring bit, whatever we are using. As we increase the number of sectors, obviously the co-channel will becomes lesser. Okay, for example, we can divide a cell into three 120-degree sectors or six 60-degree sectors, which is denoted in the below diagram. The first is a normal cell is divided into 1, 2, 3. Each directional antenna will cover the 120 degrees. So this is called as 120-degree sectoring. And similar way, even we can reduce it into further. A cell can be divided to 6 different areas. Yet each antenna has covered only the 60 degree. So this is called a 60-degree sectoring. These are the types of sectoring. And the third way to increase the capacity is called as repeaters for the range extension. Normally, the repeaters in electronics we might have studied about repeaters. Repeaters will receive the signal and okay, it holds a copy and it amplifies the signal. The same function over here. So here, in order to provide a coverage to the longer distance, that we are using a radio retransmitters. That retransmitter is normally called as a repeaters. Okay, these repeaters used to extend the range extension. Okay, so the repeaters are a bidirectional in nature. Normally, it receives the signal from the base station, okay, and it amplify it and it transmit to the users. Okay, so normally repeaters work using over-the-air signals. Okay, they may installed anywhere. Okay, normally these repeaters can be used in the buildings where the signal cannot be reached over the particular area. In that area, we can use the repeaters to for the extensive coverages. Okay, so upon receiving the signal from the base station in a forward link, and the repeaters amplifies and re-radiates the base station, re-radiates the signals in the specific coverage region. Okay, so it will act as an intermediate thing between the base station and the user. So the only drawback of using repeaters in terms of radio waves, normally the radio waves which will travel from the base station to the repeaters, that it will travels in the free space. So obviously, the noise will gets and noise and interference will gets added together. Okay, with along with the signal. So when the repeater amplifies the signal, this noise and interference is also gets amplified and retransmit to the particular area. So the only drawback is that the repeater again amplify the noise and as well as the interference and retransmit to the user. This is the one drawback of using the repeaters in the radio waves. So normally, in a building, wireless penetration cannot be possible. In that for large buildings can be, we have installed these repeaters for the extensive coverage. Okay, and this is all about the repeaters. So in this lecture, we are going to discuss about what are the ways we can increase the coverage and capacity. For that, we are using three techniques. One is splitting the cells and keeping separate base station and treat that as a microcell. A second one is when a cell is divided into sectors and we are using a directional antenna instead of omnidirectional. We are providing or concentrating only that particular area to provide the extensive coverage. That is called as sectoring. And then third one is a range of repeaters. It is just like amplifiers. It receives the signal from the base station and amplify it, and it passes over to the user. So by the way, we can increase the coverage as well as capacity in a cellular system.